Welcome to estimating the population mean. So the idea here is that we want to essentially find a confidence interval for the population mean based off of a sample mean. So we want to find a confidence interval for the population mean. Based off a sample mean. So we're going to walk through the same steps that we did for confidence intervals for population proportion. And I'm going to sort of highlight the similarities and differences between when we're working on for population proportion versus for the population mean. So for understanding the problem, we should note that we're dealing with an interval. So it's an estimation problem. We should note that we're dealing with a mean or the average. And then from there, we have some main symbols that we need to look for, or key facts we need to look for. So we'll need that we have a random sample from the entire population. Let me give myself some more space. All right, so we'll need that we have a random sample drawn from the entire population. We'll need a population standard deviation. Which will be sigma. We'll need a sample size. Which is n. And we will need a sample mean. Which will be x bar. And then we'll need a confidence level. Then off to the side, let's do what we used for proportion. So for proportion, again, we were looking for that it was an estimation problem. We noted that it's about proportion or percentage. And then the things that we need, again, we need a random sample. Drawn from the entire population. And then we needed a sample size of n. We needed a sample proportion. P hat. And we needed a confidence level. So the things that we draw from the problem are a little bit different, but it's kind of a similar list. The type of information that they will give us in a problem about the mean, we will be given a standard deviation, we will be given a sample mean, as opposed to in a problem about the proportion, we would be given a sample proportion or a number of yeses from our sample. All right, from here, next we have to justify that the study was well run and that we can find the interval. So for proportion, what we needed a good sampling technique. And for a good sampling technique, it had to be random and from the entire population. And we also needed the normality of the p-hat distribution. And this was for confidence intervals, essentially the number of yeses or n times p-hat and the number of no's or n times 1 minus p-hat. We needed both of these to have 10 or more. For the mean, we once again need a good sampling technique. So we need it to be random and from the entire population. And then we needed the normality of the X bar distribution. So we had two options for this. Option one is just that the population data is normal. Or option two was that the sample size was 10, 30 or more. So again, similar requirements, and then we have a slightly different requirement for our normality. From here, we have to go to understand the sampling distribution. So we have shape, center, and spread. So for the mean, versus for the proportion. So shape, presumably it's normal from step 2. Center, we have that the mean of the p-hat distribution is the population proportion, which is what we're looking for. So this is what we're trying to estimate. And then our spread, we had sigma sub p-hat was equal to the square root of, and then we would use p, but we don't know p. So we do approximately p-hat times 1 minus p-hat divided by n. For the mean, we have Our shape again, we're presuming is normal if we met the conditions for step 2. The center, we have mu sub x bar is the population mean mu. And this is again what we are trying to estimate. Then we have our spread. And the spread here, we have sigma sub x bar is equal to the population standard deviation sigma divided by the square root of n. Going forward, for our confidence interval, the point estimate is our base, our sample statistic. All right, it sounds like I'm going to have to pause the video and come back. Okay, so for the point estimate, our sample statistic, for proportion, our sample statistic was our sample proportion. Or p hat. For the mean, our sample statistic will be our sample mean, or x bar. So this is our base guess. It makes sense that whatever we get for our sample mean would likely be a reasonable guess for our population mean, just like the sample proportion was a reasonable guess for the population proportion. And then we want to give ourselves some wiggle room. So adding in our wiggle room, our margin of error, we'd have our standard formula. So margin of error, we want to do essentially the number of hops out we need to go to get our correct percentage times our standard deviation. So the margin of error for proportion was, your textbook uses the symbol z sub c times the standard deviation or standard error for the p hat distribution. And z sub c was for 95% confidence, or let's do 90% confidence, z sub c was 1.65. For 95%, it was 1.96. And for 99%, we are looking at 2.58. So it's exact same idea for the margin of error when we're dealing with the mean. The margin of error is z sub c times the standard deviation for the x bar distribution, since we're talking about the x bar distribution in this case. Again, same rules. For 90% confidence, we use a z sub c of 1.65. For 95% confidence, we use 1.96. And for 99% confidence, we use 2.58. Then from here, to find our interval for proportion, we took our p hat, our base estimate, our point estimate, and then we went up by our margin of error, down by our margin of error, and then this stretch was our interval. For the mean, our base estimate, our point estimate is our x bar. Then we'll go up by our margin of error, down by our margin of error. And we have our interval for our mean. So this process is almost the exact same process that we used for the confidence interval for proportion. It's just that the numbers we're using in the calculation for a standard deviation is slightly different. From here, we draw our conclusions. In both cases, we have our generic formula or our generic statement. I am blank % confident that blank falls between blank and blank. So this first one is your whatever confidence level. The next blank is whatever we are trying to estimate. And then this is the lower end of our interval. And the upper end of the interval. So again, the process, the steps are essentially the same steps that we used in finding the confidence interval for the population proportion. The main difference are point estimate. We are going to use X bar instead of P hat. The calculation for our standard deviation or standard error is now different. The justification for normality is now different. We're in a different situation. We have different rules for what makes it normal. And then there will just be a little different information that we pull out of the problem. But other than that, it is basically the same process for our confidence interval.